The torque converter is often seen as the most complicated part in vehicles of today. It is, however, a very important component of automatic transmissions. This animation explains the theory behind this complex component. The first part of the torque converter is the impeller. It has curved blades and is filled with fluid. When the impeller spins, the fluid will be thrown outwards by centrifugal forces caused by the rotation of the impeller. The faster the impeller rotates, the higher the centrifugal forces. The turbine is situated opposite to the impeller. In fact, you could say that the turbine is an impeller rotated by 180 degrees. The fluid flow from the impeller is directed over the blades of the turbine, so the turbine rotates. The blades colored in red are those of the impeller. The yellow ones are those of the turbine. Here we can see that the yellow blades of the turbine are much slower than those of the impeller, because, for example, torque conversion and energy losses between impeller and turbine take place. Let's have a closer look on the flow of the fluid. The fluid in the impeller is forced outwards due to centrifugal forces and transmits the energy to the turbine. The turbine's blades are installed in such a way as to allow the fluid to flow to the inner part of the turbine and in the impeller. From there, the cycle repeats itself. This device is called a fluid coupling. Here, no torque is converted. To convert torque, another special feature is necessary: the stator, which is interposed between the impeller and the turbine. The fluid flows through the turbine to the stator. The stator's curved blades turn the fluid flow at an angle of almost 90 degrees. The result is a multiplication in torque because the fluid flows back more slowly. The impeller is mounted to the housing, and the housing is connected to the engine. Consequently, the impeller receives the mechanical energy produced by the engine. In general, torque converters use a lockup clutch that will be explained later on, and a turbine output shaft that connects the turbine to the transmission and the wheels of the vehicle. Torque converters have 3 stages of operation. The first phase is called stall. Here, the engine applies power to the impeller, but the turbine does not rotate because the driver keeps his or her foot on the brake at traffic lights, so the vehicle does not move. The second phase is called acceleration and takes place when the traffic lights turn green. The brakes are not applied and the driver presses the accelerator pedal. Consequently, the impeller rotates faster, but there is a relatively large difference between impeller and turbine speed. Under this condition, the converter produces torque multiplication. For acceleration, this torque multiplication is needed. The third phase is called coupling. The vehicle moves fast. The turbine has reached approximately 90% of the speed of the impeller, and the torque multiplication has ceased. Now, the torque converter is a simple fluid coupling. Modern vehicles use at this stage of operation a lockup clutch to lock the turbine to the impeller. This eliminates losses associated with fluid drive.